All right, so solving a rational inequality, the first thing you do is make it equal to 0. So I'm going to make this equal to 0. Okay, and so 2x divided by x plus 1 minus 1 is greater than or equal to 0. Now, the next thing you need to do is you need to get a common denominator here, because these two need to be, you need to have like terms here so you could subtract this. So what does this denominator need? I'm going to erase this here because I need more room. What does this denominator need that this one has? An x plus 1. So you're going to multiply the top and bottom here by x plus 1. Okay, and that's greater than or equal to 0. So what I'm going to do is I'm going to distribute -1 into there. Okay, so I'll distribute -1 into there. So 2x and then plus -1x minus 1 divided by x plus 1. And if you have a common denominator, remember, like 1/3 plus 1/3 is 2/3. The denominator doesn't change. I'll get to the inequality here in a moment. I'm just simplifying this. It's going to change the numerator. So 2x minus 1x is 1x minus 1. So that's greater than or equal to 0. Now, what you need to do next is you need to figure out your boundary points. So how do you figure out your boundary points? Well, there's going to be two boundaries you have to consider. You have to consider the x-intercepts, which makes the top equal to 0. And then you also have to consider asymptotes, which makes the bottom equal 0. So set the top and bottom equal to 0 to get boundary points. Okay, so x minus 1 equals 0, x plus 1 equals 0. This is not too bad. Add 1, x equals 1, subtract 1, x equals -1. Now, we've got to kind of, for later, we need to know what those boundary points represent. This boundary point right here represents an x-intercept. Okay, this is the x-intercept. So that's what makes the top equal 0. And then this represents the vertical asymptote. And this is going to be important later on in this problem. Okay? So now I'm going to make a number line that contains these boundary points. And I'm going to have a few more. So -2, -1, 0, 1, 2. So I've got a boundary point at 1. Got a boundary point at -1. Okay, so let's look at these intervals. So this interval here would be from -infinity to -1. This interval would be from -1 to 1. This interval would be from 1 to infinity. So I've got to plug in values in those boundaries into the expression to see how they satisfy the inequality. So remember, my simplified version was x plus 1 divided by x minus 1. So -2 minus 1 divided by -2 plus 1. -2 minus 1 is -3 divided by -1. So that's +3. So that's going to be positive. Okay, let's do 0 next. We like 0. 0 minus 1 divided by 0 plus 1. -1 divided by +1, which is -1. So this one's negative. Let's do 2. 2 minus 1 divided by 2 plus 1. 2 minus 1 is 1. 2 plus 1 is 3. So that's positive. Okay? Now, what did I need? I need values that were greater than or equal to 0. So who are my winners? It's my positive ones. Okay, it's my positive ones. Now, this is where you've got to be careful, okay? It does have an equal to, so that means I do need to include the x-intercept. But you do not include the asymptote because it's never going to cross or touch the asymptote. It's never going to equal -1. It can't equal -1 because I'd make the bottom equal 0. You can't have that. So it can't equal so the vertical asymptote is not included, okay, but the x-intercept is included because it has an equal to. So how do I write this? I'm going to do -infinity to -1. That's the vertical asymptote, so it's not included. So I put parenthesis, union. 1 is included because it's an x-intercept, so I am including when it equals 0. When you're on the x-axis, you're equal to 0. So 1 to infinity. I can look at this graphically here too. So x minus 1 divided by x plus 1. You can look at this graphically if you wanted. And so we're looking for the points where it's greater than or equal to 0. So I'm looking where this graph is greater than or equal to 0. You see how it's greater than or equal to 0 for that region? So for negative infinity to -1, and then starting here, it's not, and then starting at 1, it's equal to, and then it's greater than from there on out.